Hi, this video we're gonna see how we should solve the integral of 0 to infinity of 1 over 1 plus x to the power of I dx, with I being a square root of -1 and having the property of I squared to be -1. So, how should we solve this integral? Because this is a complex one, not like ordinary things, and it's a little bit hard. But what I'm going to do first is I'm going to define x to the I to be tan theta, tan squared theta. And thus, if I do a little bit of change of basis in the powers, I'm going to get x equal to tan theta to the power of 2 over I. And if I now differentiate both sides, I'm going to get dx equals 2 over I tan theta 2 over I minus 1 sec squared theta d theta. I'm going to be left with this. So I can do this substitution in my integral here. The integral from 0 to pi over 2 if I change the bounds of 2 over I times 1 over 1 plus tan squared theta times tan theta 2 over I minus 1 sec squared theta d theta. 1 plus tan squared theta is secant squared theta, so these sec squareds are going to cancel out, and I'm going to be left with 2 over I, the integral from 0 to pi over 2 of tan theta 2 over I minus 1 d theta. And I can write and use trigonometric identities and say it is sine theta to the power of 2 over I minus 1 times cosine theta to the power of 1 minus 2 over I d theta. Now, remember beta function, beta of m and n, to be equal to 0 to pi over 2 of 2 times the integral of 0 to pi over 2 of sine x 2n minus 1 cosine x 2n minus 1 dx. Now, I want to have this result in terms of beta function, so I'm going to say 2 over I minus 1 is 2m minus 1. These two are going to go away, and m is going to be 1 over I. Now, 2n minus 1 is going to be 1 minus 2i, 2 over I, and 2n minus 2 is going to be negative 2 over I. 2n is going to be 2 minus 2 over I, and thus it's going to be 1 minus 1 over I. And it's going to be this. Now, remember that beta function also is beta of m and n is the same thing as gamma function of n, gamma of n over gamma of n plus n. Now, if I write the beta function in terms of that, if I write the beta function of what is my m here, 1 over I, and 1 minus 1 over I, it is gamma of 1 over I, gamma of 1 minus 1 over I, over gamma of 1, which is 1. If you add 1 over I plus negative 1 over I, you're going to get gamma of 1. So my integral is 2 times 2 over I times gamma of 1 over I times gamma of 1 minus 1 over I. This is my integral that I'm left with now. My integral first is going to be 1 over I times beta of 1 over I, 1 minus 1 over I. Secondly, if I want to write it as in terms of beta function, it is going to be 1 over I times this thing right here, and according to Euler's reflection, it is going to be pi times sine pi over I, which is pi over I cosecant of pi over I. Thus, the integral from 0 to infinity of 1 over 1 plus x to the I dx is going to be pi over I cosecant of pi over I. And that is the neat result of our integral here. Thank you for watching this video. Please like and subscribe, and I'll see you next video.